Hello everyone, this is Mustafa. In this lecture, we will explore Raspberry Pi configuration and then we will see how to create our first Raspberry Pi image. As you recall, our BSP layer that we downloaded is called Meta Raspberry Pi. This layer comes with support for Raspberry Pi 5 machine. We have already added this Raspberry Pi 5 machine to our local conf file so that the build system is aware of the fact that we are building for Raspberry Pi. In order to create our first image, we need to take care of a few things. One is to make sure that we set up console parameter correctly so that we can see the boot and the console output from the correct UART port. Second thing we need to take care of is, since we are in the debugging stage, it would be good to add an SSH server to our image so that we can also use SSH communication in order to connect to our board console. In this lecture we will be exploring these options, but first let's talk about the introduction to the Raspberry Pi 5 hardware. I will not go so much into detail as I expect the listener to be familiar with the Raspberry Pi already, but to put simply, this is a single board computer that is very popular. There is a big community around it. Most of the things, besides a few firmware, is open source. That is actually why we are using Raspberry Pi 5 for this lecture. Checking the specs, we have enough power for many applications. If you would like to implement some deep learning or tensor application, you can look somewhere else. Or if you're looking to develop some time critical application, you can look somewhere else. But other than those GPU intensive or safety critical applications, I think Raspberry Pi 5 is more than capable of handling many tasks. It has sufficient RAM, a good ARM Cortex A76 based SoC. SoC is called BCM2712, and it also comes with a lot of peripherals and connectivity support. It has 2 mini HDMIs, gigabit Ethernet, USB 3.0 ports, Bluetooth, Wi-Fi, and this recent Raspberry Pi 5 comes with a PCIe interface also, which is really good. One thing that is important, Raspberry Pi comes with one peripheral or I/O controller chip. You can see here that is called RP1. This one is really important. This RP1 peripheral controller chip is essentially connected to the SoC via PCIe, and it is handling communication to the peripherals. So when we are experimenting, if you see the name RP1, I want you to remember that from now on we will be seeing this in the device tree configuration also a lot. RP1 has this beautiful documentation. Actually, let's go ahead and check this documentation real quick. I've already opened it here. Here is basically the data sheet for this, and there's a lot of information here, how registers are looking and how to configure stuff. Unfortunately, we don't have time to check all of this, but when it is required, we will be using this. Let me take this opportunity to actually download this for our documentation. So let's go here, docs, and let's save it so that you can also have access to it easier. Alright, also let me show you this one real quick. If you simply search online Raspberry Pi documentation, you can find this web page. This web page is great. It not only has all the data sheets that you can have access, not only for the Raspberry Pi itself, but also for some of the extra peripherals that it uses. There is documentation how to configure Raspberry Pi config.txt format, for example, how to configure the kernel. Really good starting point as a resource if you would like to get more familiar with the board itself. Okay, let me also copy this and put it to our documentation. First, let's switch workspace. Okay, let's say here Yocto documentation, and we will also have Raspberry Pi documentation. Also, let me try to copy the second one and paste there as well. Okay, beautiful. So now I think we can now see what we need to do in order to simply generate an image. How to invoke bitbake command on a image recipe file there. As I mentioned before, base image for the Poki distribution is called core image minimal. This is a very simple image, and it is good practice to use that one. Just to recall, let's find that real quick. Okay, so it is this exact image recipe. You specify what will be installed by giving recipe names, separating them with the spaces, and here you can see the main recipe that will be installed actually is this one, package group core boot. You can see that it is using core-image bb class, and there is some implementation in this file that is taking care of all these variables, and based on these variables it is doing some action, either some Python script is going there or some bash script. Okay, so this is the image that we can use to start with, but let's just first explore what it has. Let's actually start by investigating this core image. Okay, I can see the recipe file here. And let us go down to check what it includes. Okay, it is simply defining some other variables, and then it is inheriting something called image. So this is also a recipe file. So let's check what is inside that. And here we have some more variable declarations to prepare everything, right? And then we have some Python script basically, and as you recall, we can define Python scripts and we can use this Python script to assign to a variable. And let's go down, and we are starting to see the simply task dependency declarations. We can actually see the actual task here. So whenever we bitbake an image recipe, there's this do rootfs task that will be simply executed, and this is Python code, as you could see, and it is getting many variables. Simply it is reading these variables from the bitbake environment, the variables that are already declared in the recipes that are above this class file, and then based on these variables it is doing some action. It is creating the rootfs, and yeah, there are many functions that it uses for this, and yeah, you can see there are other tasks that it defines. I wanted to show you these functions so that everything is clear from your perspective, because we will analyze what sort of tasks are taking place in the image recipe. So I just wanted to show these first actually. Okay, so basically this is some rootfs generation, and making sure the image is correct and doing some quality assurance on that based on the variable that we defined. If we are clear on that, we can go back and we can simply see that image install is using this recipe, so we can try to check what's inside this recipe, what this recipe depends on, so that we know what is installed actually when we bitbake this core image minimal. So let's quickly also find this one, package group for boot. So we can immediately see that this recipe, this package group, depends on these recipes. This is a runtime dependency. We have also build time dependency, but we will explore it when we're dealing with the recipe files. In a minimal distro image, you can expect an init system, EFI, and some netbase package, some recipes that are pointed to by using variable. You can also check by simply searching these variables, and update alternatives I'm seeing, and it looks like it. And let's not forget, these are not the only ones that are going to be installed. The dependencies of these will be installed, and second, whatever is added to this variable will be also installed. Okay, here we are setting the rootfs size. So in order to simply bitbake this, first we needed to add to the local conf our machine. We already did that. It is Raspberry Pi at the moment. So now we can simply go over to our Poki, initialize the environment, and we can execute this command basically, bitbake core image minimal. But before doing that, this will take some time, of course. Before doing that, I'd like to show you how to check what will be installed by recipe with an easier command. So if you use bitbake with the -G flag, G option, then it will take a very small amount of time, and during that time the dependencies will be calculated, and you will get some file that includes what core image minimal actually depends on. Let's go ahead and do this first. We are now only checking what core image minimal will depend on. Later we will check which tasks will be executed. We have already seen them in the ImageBB class, and we will check them also. I just showed you this ImageBB class, right, and how this image is actually being constructed. But we need to also remember we have this Meta Raspberry Pi layer involved. So this Meta Raspberry Pi layer has this machine configuration, right, for Raspberry Pi 5, and this machine configuration will always override what's in the meta layer. So if we are overriding what sort of ImageBB class to use in this file, then instead of the default method to create image, the image creation method that is described in this file will be used. So we didn't explore what happened in the Meta Raspberry Pi yet. We just explored the default core image minimal behavior. But we will also get to this point. So we will explore what Meta Raspberry Pi is adding in terms of image generation. Because when we are doing bitbake core image minimal with the Meta Raspberry Pi included, it has the ability to directly generate an SD card image, something that the Raspberry Pi community has added. As you can see here, we have the SD card underscore image dash RPI BB class, and I expect this SD card image RPI to be simply referenced somewhere in the machine configuration, so that instead of the base image building methodology, this one is used instead. Okay, so bitbake G core image minimal command has been successful, and it is saying that we have this pn build list and task depends dot files saved. So let's go ahead and check what is the content of these. Okay, this is the first one. This is the second one. We're mostly interested in the first one though. Okay, as you can see, we have a list of packages, 236 packages, and it starts with the core image minimal. This basically means that when we bitbake core image minimal, all of these need to be bitbaked. Doesn't mean that all will be included in the image, but these all will be bitbaked. These are either will be deployed or dependency to something that will be deployed basically. So this is really a good way to see what will my recipe file depends on. Okay, so let us continue. In the beginning of this lecture we said that we need to deploy some sort of mechanism in the Raspberry Pi 5 image in order to be able to communicate with it, right? So we have two options. In this case, we have first the serial, second is the SSH server. We will be doing the both. SSH is easy. All we need to do is hook our Raspberry Pi to some sort of network and make sure our development PC is also connected to that network. And then we need some SSH server in our image. We have explored already the options before. We have OpenSSH and Dropbear, and since we already explored a lot regarding the Dropbear, let's go ahead and simply add this Dropbear package to our image. How can we do that? It is really easy. we're just gonna go to build conf local conf, and here we can simply use image install command. Image install command will be actually appending it, because we don't want to overwrite the already constructed image install variable from the recipe files. We just want to add something to it. So we will say, we will stick with this notation. We will say colon append equals one space, and go to the middle and type in drop here, I believe. But just to check if there is anything more proper to give here. So I know there is drop your recipe, but if this drop your recipe needs additional configuration, and if there is a recipe file that already includes that configuration, I would like to involve that one instead. So in this case, what I can do is try to search for SSH maybe. I have package group here. Package group would be better for sure. Drop your SSH client and service includes the client as well. And what else? Let me actually search it. Yocto add drop your SSH support. Let's check. Is it really this simple? Alright, I was searching for this one. Apparently you can install Dropbeer, or you can install SSH server by using two methods. One is directly giving the recipe file in the image install variable. The second is there are some pre-constructed feature strings in Yocto that you can use. These are called image features. So if I try to search image features Yocto, hopefully I will get some manual explaining this. Okay, yeah. Here, for example, it is already telling me that, yeah, there are some features that the Yocto already implemented in the meta layers, and we can simply append one of these strings in order to add some support directly in the image. We don't have to deal with the recipes and so on. So these are really core functionalities. Of course, SSH service considered core functionality. For example, if you would like to also add some debugging stuff, you can also add this one. This is also good to know. So for example, if you would like to add support for splash screen, you can use this one. So let's go ahead and try to do this with the image features variable. So let's go on to here. I'm expecting this one to also work, by the way. I'm not saying that this won't work, but I just want to avoid any extra overhead at the moment, so I will go with what's tried and true. And you can say image features append. You can copy what's already available here, and that will be it. You know what, we can also check what this does. Should we do that? I don't know. Let's try to check what this does. Feature packages. Okay, this is essentially this one. So it is installing package group core SSH drop here. And if we search for this one, what does it have? Besides the drop here software package. Okay, I think it is also installing the SFTP besides drop here. There's not much going on actually. So you can go with either. So three methods. You can use image install append, drop here, or you can use what's available already as an image feature, or simply you can install also this package group by using image install. Okay, let's go with the feature for us. As you can see, we have added this not to the core image minimal recipe file, we have added this to localconf. That's an important factor. Typically we don't want to manipulate anything in the layers that we don't control. So I have already this MetaMouse layer. I have also option to simply added here in the layer configuration. But if I added this to here, it means that this feature will be only inside this build when this MetaMoz layer is included. If I do this in the local conf, it means it is global. If I remove this MetaMoz layer, it doesn't matter. So it's whatever you choose. For the sake of simplicity, for our lecture, I would like to implement these variables only in one place, which will be this local conf, and I'll be only adding recipe additions to the layer. But you can go with either option, as I said, so you can also add it here. Alright. So that's done. It's really easy, just adding one package, and since I have added this already, I can go ahead and check if it is indeed added. So what I'm gonna do is I'm gonna bitbake g core image minimal, and then check the updated file. Alright, let's check. Let's search for Dropbeer, and then you can see it. Dropbeer is indeed gonna be processed when I try to actually bitbake this core image minimal. Alright, so that's one thing done. Now we have the Dropbeer SSH server inside our image. We can go on with the second one. Second one is the UART support, because I want to be able to also see the boot messages. If there is some kernel crash, if I couldn't get to the SSH, then I'd like to be able to debug this boot process, right? In order to be able to do that, I need some serial. There are basically two serial ports on Raspberry Pi, and I can hook one USB to UART converter to Raspberry Pi to either port, and then connect this USB to my PC in order to be able to use this serial terminal programs from my PC to be able to simply see the boot outputs. Okay, so as I said, there are two ports available to the user. One is this special connector between the two mini HDMI, micro HDMI ports, and for that, yeah, you might need some specific USB to UART converter. The one that I have doesn't have that port, so I don't prefer this option. There is second option. Second option is to use this 40-pin GPIO, and the GPIO pins for the TX and RX are given here. You just need to make this configuration to your USB to UART converter in order to be able to use this port also. Okay. By the way, this is a picture of some older Raspberry Pi, but the port location didn't change, so pins are the same. One important thing to remember is that Raspberry Pi pins are 3.3 volt tolerant, so just need to keep that in mind. You cannot go higher. Just don't hook up a 5 volt for your safety. Sometimes nothing happens, but for safety I wouldn't advise it, and you'll be good. So you need to obtain one of these things, USB to UART converters. Alright, second thing is these UART ports have names, and I have searched for the names and I found them. So the one that is in between the two HDMI ports are called TTY AMA 10, and the other one which is on directly at the 40 pin GPIO header is called TTY AMA 0, right? So since I will be using this, I will need to do some configuration. Okay, so let's check how we can configure the serial port that we would like to configure, which is called TTY AMA 0 in our Poki Linux distribution. Alright, so let's go back to the code and let's check for the serial port here. Alright, as you can see in the machine layer, we have this serial consoles that is defined, and it is set to TTI AMA 10 at the moment, so we would like to switch this 10 to 0. But as I said, we don't want to do any modification inside this Meta Raspberry Pi layer or any of the layers that we downloaded, so we have two options. We can either do this modification by simply creating a new machine based on this one in our own layer, but we will tackle this task in the future, or we can simply use this local conf, our global configuration, to override values for any variable. So what I'm gonna do is I'm gonna copy this and I'm gonna paste this to here, and I'm gonna change this 10 to 0. This is the first thing that we would like to do. Okay, when configuring Raspberry Pi regarding some drivers, there are two files to keep in mind: config.txt and cmdline.txt, because as you recall, we have these files simply determine how the kernel will be configured. This command line parameter that will be passed to the Linux kernel, and configuration, config.txt. So let's go inside Meta Raspberry Pi layer and let's check these files. So there are recipes for creating these two. This file that I'm highlighting is responsible for creating the cmd line txt, and the other one is used for simply creating and deploying config.txt. So first here, let's check what is there. I'm immediately recognizing one variable, cmd line serial, and this is used inside the cmd line variable, and cmd line variable is used for simply creating this cmd line txt file, and then later at a later task, at the deploy task, it is deployed to the boot files directory. Alright, so what we can do, since we would like to overwrite this, we can directly copy this and we can paste it here. And yeah, we don't want the default assignment, we would like to override it, so let's go with these. And before continuing, let me explain these conditionals. So this is bitbake conditional that is referencing to a simply Python function, and what this function does is checks this variable that you give as a first argument. If this variable is equal to the second argument, which is 1, then it simply writes this text, and if it's not 1, it adds this text. But for now we don't need any conditional here, so I'm gonna remove this conditional, and I am going to simply modify this serial 0. I'm gonna say TTI AMA 0. Okay, so we found some serial console occurrences in Meta Raspberry Pi, and we started overriding those variables in our local conf. Okay, and third thing I have noticed is this enable UART variable. So basically you can get all this information also by simply going to the Meta Raspberry Pi layer, and there's this documentation you can check, but I'm trying to be explanatory as I can. So enable UART, I'm wondering where this is used, so let's go ahead and search this. It is used where? It is used here in order to write something inside the config.txt file. So we can enable this. We should be enabling this. Let's go back and let's type in enable UART equals 1. And final thing, actually that's the thing that we should have done first, is to check device tree whether UART 0 or TTI AMA 0 is enabled or not. So for that, what we should do is we should go back to the machine layer here, and we're gonna find some references. Let's check the includes. Okay, as you can see in this RPI base.include file, we have our device tree overlays and our device tree lists that should be simply compiled. We have our 5B main device tree, but what we should be doing is we should be adding support for UART 0. So let us search for it, Raspberry Pi documentation. And maybe go to this DT overlay of UART. Let's search for UART. As you can see, we can notice here UART 0 is indeed TTY AMA 0, but that's not what I was looking for. I was looking for enabling the device serial overlays from the config.txt, and I found one example here, dt overlay equals. So we will be first adding the device tree overlay to this list so that we make sure that it is compiled. Then we are gonna also add we are gonna enable this device tree overlay by simply stating it in our config.txt. So let's try to find our kernel. So basically our kernel is downloaded from this repository, some branch that I don't know, but we can easily check if such a device tree overlay exists in order to enable the UART 0. So we're gonna go there. We're gonna go arch arm boot DTS overlays, and yeah, this is we would like to search it here. And there is indeed this overlay. So this file is basically making modification without touching the main device tree file, and it is simply setting the status to OK for this device tree node and setting the pins that will be used. So we can copy this name and we will be adding it to this variable. So first we wanted it to be outputted, we wanted it to be compiled actually. In order to do that, we should add it to this list. And yeah, we can also do it here. Simply we'll be appending it. Just make sure they did alright. What we can do is we can do something like this: append equals overlays UART 0.5 DTBO, and let's keep this multi-line structure that they were using. So let's do it like this. I believe we have 4 spaces here, so let's give also 4 spaces. Alright, so what we did, we set our main console to TTI AMA 0, and then we have simply made sure that this UART 0 Pi file is compiled. This variable is used later on in one of the recipes in order to make sure that this is compiled. And then the last thing we would like to do, as I've shown you in the config.txt, we would like to add this DT overlay. So in order to do that, since we will be modifying some file, we will be creating a recipe append file. So let's first check what they did. Yeah, I have already some example here how they added any DT overlay, right? So I can simply copy this. I will be tailoring it, of course. Then let me keep this layer structure in order to create an append file. It's good to keep this layer structure in your own layer in order to override it. Alright, so we're gonna create recipes BSP, and then we are gonna create both files, and inside it we are gonna create a BB append file that starts with the same name. So the package name and version is the same, but we are gonna add an append at the end of the extension. and I will be copying everything, but I will be removing most of the things after it. So in order to append something, in order to append a task, we just need that task. So let's remove anything else first. All these definitions are already done, so we don't need to do it. What we do here will be executed on top of the what's already available here. And then let's only keep our example, which is this one, inside this task function. And then let's also get rid of all these extra stuff. And here we will be simply saying you're at 0, pi 5. And this will be simply added to this config.txt as a separate line. Let us take a build and check what we did. Actually, I made a mistake. I should have had this append here, because I don't want to overwrite this do deploy. I just want to append some line just at the end of this do deploy function. I want to keep all this. That's why we added the append here. In one of the later lectures, we will go into detail about the syntax, but for the sake of our purpose, we just enable serial and SSH. I think this is sufficient to tell you that you should add this. Let's start it again and check. Alright, so the build is now complete. Let's check our output. I'm gonna go inside this directory, then I'm gonna go to this command line recipe first and find the command line file, and we can check. As you can see now, our kernel command line, which is passed from bootloader to kernel, states this console equals TTI-AMA0, which is the serial console that we want to redirect the kernel output to. And during the boot, we will see these dmask messages, right? And these dmask messages we'll be able to see. And here we are basically instructing kernel to redirect its output to this serial port. Alright, so, but of course, in order for this to function, we should have this driver available so that we have this console available in the system. So we did that by doing configuration in this config.txt file. And let's go ahead and search for the config.txt. Deploy config naming. Alright, let's get this file. And as you can see, we have added the device tree overlay, which simply enables the driver, which is good. And also we have this enable UART equals 1 statement. So basically all the modifications that we did here and the bb-append file that we added here achieves the tasks I just showed you. With this now, when the board boots, we will be able to see the serial output, but we will do this in another lecture. So that being said, thank you very much for following the lecture, and I will hear you in the next lecture.
下，我那份资料组比较甜，把它做完。我记得你传给我那份资料，我去年没有听过。那个可能是过时候。
数位又想要吃火锅，右上角。又想要吃
这天气吃火锅最很想吃
不知道，我去。
哎，好屌，你穿这样哦。
谁？
你啊，帅，再脱啊。
再脱再脱。好屌哦，你都不会冷，其实还好。就是冷气它太不冷，其实我。
拜拜。
对，就好像那时候
拜拜。
他们有带，
晚上。
我好像有带你。
这个在。
他们那，他们那时候订的，好像是12月。就他们有些在学校。
我那个一颗是算。
因为我那天在看，我有在想说，哎，他们那时候有这样。
可是这样子的话，是不是变成，可能到时候你填的话，你要找一个人填。因为我们这一届5个人，然后他们这一届也填。
自己带，没关系没关系。自己填。
哦，你也蛮挺我。
那个是不受伤，
其实如果要写的话，就变成说，就是因为我也自己有听过，就是我也可以写一个报告。
他家在公园，你知道吗？他家在公园。特别在风俗公园。然后可以再训练好。
你偷我东西啊？
哎，我也有这一本。不行，我今天要健身呐，我前2天都没去啊。
要前几天拿来看看。
我已经。
我们事情多。我现在下一个很忙，我现在下一班先搞这个，搞这个把手术做出来，把那个ESG跟那个配送。
你拉单跟拉50下才多久？
不行。读书要紧。
是你们在那边 A 的时间，在那边跟我说读书要紧。
啊，我昨天是因为我在早上的时候一先把进度，我每天都有进度，他就传一下。
可以了，不错，
我得
优的嘞。那可
可
以拉单杠吧？
没有这个
早上都有进
进度
度了。
这个我今天早上都没干嘛好不好？10点才来。
让一个口译。
啊，这个12点才来。啊，今天我几点来的？
哎，所以他们都晚上那么读到凌晨2、3
我没有。
点才。
没有，我家就我那电视剧都这里。我要这边做完做完。
推荐电脑。
哎，你这样你可以看一遍啊。
不要，我不喜欢，我不喜欢，我不喜欢听音乐，听忘记。
这样更糟糕，一直都有。
啊，要回家吃啊。要回家吃。要回家吃。
他没有，他过有什么话都没讲。
要回家吃嘉义火鸡肉饭。
那刚台中要吃什么？
台中是什么？
他说家要吃火鸡肉饭，那你们台中要吃什么？
台中是东泉的。
整罐当罐子。
对啊。台中吃太阳饼。我看别人吃太阳饼。
月亮。太阳。
哎，现在问你哦，就是刚刚那个，当疫情又来没收，就是你们可不可以之前报告，就是需不需要带？
就是我问同学，我上礼拜那个。
就像他们那时候，像之前换两个人那时候签的时候，就是没有啊，因为你们就没有。
查一下查一下。
猪肉吗？
其实我们有给钱，
猪肉。
如果是想喝
所以
饱食，就
我们要写，
可以吃油。
其他都不用。所以不
我今
用带，
天没花钱。
因为这个也是政府
我今天没花钱。
因为我们之前去不是有去年。哦。然后就想申请什么？
就那个不要屁就行。
之后你们一起吃吗？
吃饭他们吃饭该吃啊，吃饭该吃。
吃饭可以吃卫生间，那可以吃一点。
有时候可能会有一点6点了。
第二层。
不行，这蛮好笑的。
200多，没有啊，我没放210，最便宜。
没有，素食199，还是多少？
素食199贵，
算是吧。
不行啊，我要蛋白质。
那个豆腐啊。
不然每次想吃什么？都可以啊，我没意见。
好，那你可以现在可以选2号。
你想吃哪一类？
椰肉块。
怎么跳的那么突然？
椰肉块。
健康的感觉。
对啊，很多菜。椰肉块很健康。
原钻啊，原钻。
不行啊。
哦对对对。
原钻昨天被那个苏伟哥一直洗。
不嘛？怎么怎么了？
我们变这个
回来的时间
为什么？
太过分
了。臭。
你昨天晚上
很臭。
这也是过来。
臭。
是吧？我的肉也过很，感觉超冷。
它那个有一个味道，我就是觉得食不下咽。最后一块猪排你再
怕冷的人最帅。
有那么夸张吗？
然后你那个打开门进房间，发现5XX5。
我觉得
那会食不下咽。
你还想吃？
真没有吗？
马上去运动。
可是我发现那个窗户。
是马上去运动。
对啊。
现在。
就是那个窗户的
等下说我要去运动。
密封。
健身啊。
9点才可以进去啦。
就是我觉得房间跟外面差很大。那就是窗户关锁太紧。
我先去厕所，跟你讲，好不好？可以吗？可以吗？给我
想不到可以
厕所时间。
我房间可以那个短袖短裤。
可以吗？可以给我一个厕所。
就是是的。我不知道，可是有时候你比较想要裸露，我会觉得不太行，不太行。
你平常至少你试试，你发钱呐，怎么突然想吃有肉？
他就因为欠款啊。欠款吃饭就算了。
还是因为我睡觉都是
这边附带附到。
我开讲，我们这没花钱。
快点问那个安静讲，我想吃什么？
你要吃什么？没有啊，
你先让我想一下，你先让我想一下，我去厕所还没打。
不能缺少，你不行缺少。
好，你说。
翔哥。
你说，没有人可以碰到我的床的。
翔哥。
你看起来好像卖药。没有，你房间隔热好。
还不错。
真的。
好了，苏伟。
误差很大。
就那个。
会吗？你房间误差跟外面。差很大。有没有可能是方向的问题？
你房间冷。
我房间很热，他房间也很热。
就因为它是侧的啊，我们是侧面啊，它风吹，而且我们是前面有，我们就是
风向的风向。
就不会想要，就不会开头再出去。穿短袖。
短袖短裤。
怎么讲？不开电风扇。
你那边会开哦？
我以为。
那你那边会不会其实比我？
有可能。
我会开。但那个是暗进的，我觉得有点。你那觉得？你后面有防水。
有啊。
多啊，你那就不在意，因为我前面点到车身。
我听得到10公尺。
我听得到隔壁巷子那个开关载回来的那个。
我听得到楼下施工的声音。
那对啊，那个还好，但我听得到马路的声音。
没有，楼下施工声音超大。
好，听得到。
不知道跑步靠不近。直接开电风扇。
苏伟哥。
好爽啊！
有人说又是小贵。
超贵。
不然你不知道。没有。我们这里我们是先进考试。没有。
已经到了。
那个没有新的。
哇。
还是
这样吗？已经是有啦。哇。
那个新皮
好。就是拿珊瑚去点，塑胶不是玻璃。好，然后取点作废。你记得哦，主要做这些的话。我没有做正规化效果。
先透支一下，我就是这种心态。
没有。我们就把话
对，等下先做一次。
但它原本就已经不行。
我们
刚刚不是火锅吗？不是火锅。
好吧，我们来这里煮火锅啊。好酷哦，为什么会有那个颜色？自己画的吗？好强啊！还是我们自己画的，我直接把它那个用起点画一个公主，老师自己把它爬的。没错，就是这个叫爬。后面我们要写要跟没法。
昨天说6个门。
哦
六门，六扇门。
6扇门。想一个6扇门可以吗？
六门可以。
好呗。
减40块就可以，怎么会这样？
减40块。
哎，减40块，他就从100到200了，那个成绩就不一样了。不是啊，不是，你先那你去16扇门试试。我听听。不是便宜的啊。啊，就是160嘛。
40块。
那就是160。啊，你12块可以讲，你有自助放那个菜可以。
40块钱。
6个门可以啊。
那还是这边直接跟着说我们是阿亮。
啊？
在这边跟着说我们是阿亮。
他说还是要吃云钻。
麦当，他自己去吃啊。云钻他自己去啊。
做一个你传讯息，你跟他说你昨天吃了什么？
因为你回答说福盛挺可以吗？
福盛挺更硬哦，要200，300。
他一定说不行好不好？
确实，福盛挺跟有肉差不多了，还比有肉贵一点。
对吧？
所以他要吃的。
有那么夸张吗？云钻没那么夸张吧？
他说什么那个照烧酱很水。
刚我还好。跟夏威夷比。
夏威夷蛋。
夏威夷超赞。
差40块而已。
40块也是钱。
对啊。
可以买没有？可以买哈德。
啊？
钻石买啥？
车钥匙。
哦，哎啊，钻几堂可以吗？钻几堂？站着。
啊？
钻几堂？
钻几堂好，也是小火锅也不错，也好吃。
对，我可以带你去。它价位跟6扇门的
钻石在哪边？
在。
哦，哎，我们之前有一次聚餐在那个，我们之前有一次聚餐在那里。可是我不知道是哪里。在火车站附近。
你说浅草6号那边？
对。
浅草在日本。
哦。
哎，你的车钥匙我有点印象，你去过？我有看到他插在你的汽车上。
哦，那只有
没有那个，没有吧？
那就送。
要走啦。
对，我回去了。
拜
拜。
拜拜。钻石。
那我没有拔吗？
那我可以跟你讲一下，我今天早上的时候截下的画面。
现在吗？
没有啊，我是跟静伟讲。
他说有什么？
哦。
等一下，啊。
插在这里。
哎。
我们有热心人士。
什么东西？
我要死。
我们有热心人士找到了俊伟的钥匙，然后就。
最热心的人是谁？
我就说我是战地记者，不是我。
玉成吗？玉成录这种事吗？
可是不是，可是还蛮好笑的。
是谁不重要啊？
我是战地记者。
你的钥匙。哎，说不定他没有跟你去，有可能这已经合起来了。因为有可能旁边的人在听你旁边就聊天，然后手一压。才去。
我下次他妈就拿一只板手下去打。
对我来说，我现在是直接买一台机车。
买一台机车。
不是哦。我要看谁会在那个停车场闲晃抽烟我就扁他。
没有啊，给你另外一个想法，你下次机车停在实验室，你有监视器吗？
直接骑上来。
知道了。跟老鼠一样，车都骑上来。
监视器。 正就算你
这样我就可以不用拔药了。
对啊，就算你忘记看监视器了，有人会帮你看。
哇。好哦。
这样吗？这样吗？
哎，对，不要生气。
不要生气。
所以是你啊。
你不要生气。
我和你都休息。可是这有人都霸凌他，跟谁？建中不是说不要霸凌同学？
对不起啊。
你怎么会觉得？我觉得大家都怪你我不优秀。因为我会炸实验室啊。
那明天就带着一种汽油。
你有被弄死吗？
啊？没被弄死。
加一啊。加一啊。
那你今天要回家一吗？
不是啊，我要怎么回去？
他有人先载你回家。
你有一个热心学长。
太好笑了。
不是，你是什么时候开始发现你的钥匙不见？
刚刚。
刚才发现也太晚了吧？
那你是很晚的老哥。
看了。
要回来吗？
整天都不知道在干嘛。完全没有发现。我钥匙直接崩。
整个人懵掉，是不是？早上来吃披萨，然后吃什么都忘了。
真的太舒服啦。
不会太长。
驿站通常都是深藏的一些墓碑。
等下那个路边停着全家只有。
对，他理解。
有在社会旁边不是有一个吗？
哦，我们这个呢是认。
这要吃什么？
算是。